Hello everyone. Welcome to our technical demo. Today we will be showing our product, which is called Integrated Quality Management Studio. IQM Studio can be used with SpiraTest and Rapise as an add-on to provide enhanced cause-effect modeling to your testing project. My name is Bob Johnston, and I am the CEO of Critical Logic, your host today. We are very excited to be a sponsor of this year's InflectraCon and Inflectra Partners for Technology and Services. Our session today will take about 30 minutes in 3 parts. In the first part, we will show a short concept video, which is about 3 minutes, to show you the overall view of IQM Studio and how it works with Rapise and SpiraTest. Next, we will show an IQM Studio demonstration with SpiraTest and Rapise in live fashion so you can see actually how it works. And then lastly, we'll have a Q&A session for remaining time to answer any questions or hear any comments you have. Our presenters today will be Samantha Fella on the video you'll see, Evan Masters, our Customer Success Manager, and Aaron Rickert, our all-around automated testing guru. Let's start with this short animation. Sam, take it away.
Take your test design, management, and execution capabilities to a whole new level with IQM Studio, the enhanced cause-effect modeling add-on for Spira and Rapise. Traditional test design requires a tester to develop tests that attempt to verify the desired behavior of every part of a system. This often leads to either expensive over-testing, where too many tests are written, maintained, and executed, or under-testing, resulting in costly defect escapes and buggy, frustrating software. But what if there is a better way? IQM Studio allows you to take any input, such as requirements from SpiraTest, and represent them in a cause-effect model. With the click of a button, the cause-effect model automatically generates a high-coverage, optimized set of test cases. The test generation algorithm ensures that each part of the system is fully tested with the fewest possible number of tests. This means that you get the right number of tests that fully verifies the desired behavior of your system or application. These high-coverage test cases can be automatically uploaded to your SpiraTest project, where they can then be executed using the test runs feature in SpiraTest. But what if your organization uses automated testing? The enhanced cause-effect modeling add-on can sit on top of your automation framework and automatically generate scripts in the model as well. Similar to the way Rapise Visual Language, or RVL, works, IQM Studio leverages keywords, which allows test designers, those who know best how to verify the system, to create automation scripts without needing to write a single line of code. These automation scripts, including Rapise and Selenium, are then automatically uploaded directly to your SpiraTest project, just like the manual test cases. IQM Studio also makes maintaining your tests and scripts a breeze. When a test or script is updated, IQM Studio will detect the change and make the appropriate update in Spira, allowing you to keep everything in sync at all times. If you're ready to take the guesswork out of your QA process and equip your QA teams with the ability to create high-coverage, optimized tests and scripts, then you're ready for the enhanced cause-effect modeling add-on for Spira and Rapise.
That short video gave you a high-level view of what IQM Studio does. Now for the live part and more details. Evan, Aaron, take it away.
Thanks, Bob. For our product demo today, Aaron will be playing the role of Senior Automation Engineer and Product Integration Expert, and I will be playing the role of Test Designer and Business Rep. It just so happens that that's who we are in real life, so we won't have to do much pretending in this session. So, Aaron, we are going to go over the 2 most common business cases in this demo. Can you describe these cases, and then we'll jump into the first one?
Hi, everyone. Sure, thanks, Evan. For the first test case, let's say you have new requirements and you want to create a cause-effect model to cover them. Then, like we saw in the whiteboard video, you want to automatically generate the tests that will cover these requirements. For our second case, we'll add automation script files into the mix. For both of our business cases, we'll be using the library information system as part of the SpiraTest demo project. For the first test case, Let's say we've got the requirements for the library info system in our SpiraTest project, and we want to create a cause-effect model to validate those requirements. Once we do that, we can then generate tests and automatically push those tests into our SpiraTest project. What does that process look like from your role, Evan?
Well, Aaron, let's first start with the requirements. Here we see the list of requirements in our SpiraTest Library Info System project broken down into epochs and features. One way to organize your cause-effect models is by epochs, and it sure looks like we can use that strategy here. Let's focus on the book management epoch and its features. In general, it looks like we want to be able to add books to the library, then do different things with them, like edit, delete, and associate them to different pieces of data. We can take these requirements as inputs into our cause-effect model. Let's see what that looks like. As you can see, I have already added a few steps to the model to launch a browser, log into the library info system, and navigate to the book management area. We will need to take these steps every time, so they are at the beginning of the model, and we will see later that these steps are a part of every test case. Let's take the first few features of the book management epoch and represent them in our model. I will create a new node and open the node editor. There are a lot of things we can do in the nodes, but for now I will focus on just the node name and test description. Because this node is telling the user to do something, you can think of it as a type of input or a cause node. Let's add a node to give the title of the book we wish to add. It looks like we are able to trigger an error here if we leave the title blank, so let's include that possibility as well. Next, let's add a node to select the author of the book we wish to add. Next, let's add a node to select the genre of the book we wish to add. Finally, we need a trigger to commit our input. In this case, that is done by clicking the Insert button, so we'll add a node to represent that step. The nodes we have just added are inputs, or cause nodes, and we now have enough steps in our model that we can next represent the observable outputs, or effect nodes. In this case, we have two possible observable outputs, or effects. The first is, we entered a value for our book title, and we expect it to be added to the list. The second is, we did not enter a value for our book title, and we expect an error. We can add nodes to represent effects for both of these outputs. First, here is a node to verify that the book was correctly added to the bottom of our list. And here is a node to verify that we get an on-screen error message. Before we represent the remaining requirements in our model, let's take a moment to connect these nodes together with relations. That will allow us to invoke our automatic test generation algorithm, which is a really cool feature. With just a couple of button clicks, we can automatically generate two tests from our cause-effect model. To take just a moment to talk about that, when we invoke this test generation algorithm, what we are doing is saying, give me the smallest number of tests that fully exercise every feature represented in our model. This gives us a very, very high level of coverage and in the most efficient possible manner. And it happens almost immediately, as we see here. Let's take a look at our tests. When we do, we see that the descriptions that we put in the model are what comprise our test steps. These are human-readable, step-by-step lists of instructions for executing the tests. For the sake of this demo, I have completed representing the rest of the requirements in a model I created ahead of time. Let's take a look at that model, and then we can talk about our SpiraTest integration. As you can see, this model includes the requirements that define editing and deleting existing books as well. With all of the requirements now in the model, we can again generate and examine the tests. We have a few more tests this time, which is expected since we added additional features into the model. This next part is really cool though. We can automatically push these generated tests up to our SpiraTest project. Let's see what this looks like now. What we see now is our sync feature that allows us to move tests back and forth from the cause-effect modeling add-on in SpiraTest. Aaron, can you tell us a little bit about what we're looking at?
Sure, Evan. You'll notice that our sync panel has two sides. On the left side, we see the database that houses the cause-effect models you just generated, and on the right side, we see the SpiraTest project that we're connected to. In this case, it's the Library Information System project, and we're looking at the tests, or rather the folders that the tests are organized into. From this panel, we're able to do a few cool things. The first thing we can do is automatically push the cause-effect model generated tests up into the SpiraTest project. You just select the test you want to push, then click the Add button from the left side panel. You can even create a new folder in SpiraTest. Let's call it Model Generated, and then upload our tests into it. We see in just a couple of seconds that those tests are now in SpiraTest. When a test has been updated, either by the cause-effect modeling add-on or in SpiraTest, our syncing utility will call it out so that you'll be assured that you always have the most up-to-date version of your test. Let's go take a look at the test we added in SpiraTest. Here we see the new folder we added, now in the list of folders, and if we click on that folder, we'll see the new test we added inside. When it's time to test, we can execute those tests right here in SpiraTest using the test execution feature.
That's awesome, Aaron.
I agree. What's even better than that is when your QA department is automating execution of your tests, you can do the same process with the automation scripts. This is that second business case we mentioned. Let's take a look at that process. Here's the cause-effect model that we just uploaded the test to SpiraTest from. We'll go into the node editor again, and this time we'll take a look at the scripting tab. What we see on the scripting tab is the keyword view of the automation framework that we built for the Library Information System. In other words, it's a list of predefined steps that we can tell our automation engine to take.
That's awesome, Aaron, but I don't see any code here. This just looks like human readable steps that anyone, even someone non-technical like me, could choose from.
That's right. That is exactly what keywords are. Keywords are visible to anyone, such as SME or test designers, while the code behind them is invisible until it's needed by the automation engine. This is similar to the way Rapise Visual Language, or RVL, works. In fact, we built a Rapise automation framework for the Library Information System. Why don't we script a few steps and see how it works?
Thanks, Aaron. I'll start at the beginning. The first thing I need to do is add some scripted steps to launch our browser and navigate to the Library Info System URL. We'll use Firefox for this demo. Once I'm on the home page, I can click Login link, and I'll script that step and save. This takes me to the login page where I can now script steps to enter my librarian credentials from the login page object. First, I will enter librarian into the username field, and we'll save this step, and I'll add a second step to enter librarian into the password field as well. We'll save this step, and then to complete my login, I need a step to actually click the login button, and we'll save that step. Now that we've logged in, we can click the book management button at the top of the welcome page to get to the book management area. Once I've done that, I can script the steps that go through the processes of adding, modifying, and deleting books from the book management epic. For this demo, we have again scripted the rest of this cause-effect model ahead of time, again using keywords without me ever having to write a single line of code.
That's right. I took care of all the coding as I built the framework so that you, the tester, can focus on ensuring the quality of the system using the cause-effect modeling add-on. Now that we have the model scripted, we can use the same sync feature we used to upload the manual tests to upload these Rapise automation scripts to our project. Once again, in just a few seconds, we've pushed the scripts to the project. From here, we can schedule test execution via the test sets, which will trigger the Rapise launcher to go grab those tests and execute our automation scripts.
That's great. Thanks, Aaron. Can we execute this script with the Rapise right now?
Sure, let me share my screen. I'll show you how this works. Now, if we click over to SpiraTest, we click refresh, we see the folder. And if we click in the folder, we see the new test we just added. Now, if we scroll down, you can see the steps, the 10 steps there of the test, as well as automation information here about the scripts attached to this test case in the SpiraTest project. You can also see those in the as attachments here, 2 different files that are required for automation. Now let's create a test set and execute this test. We'll create a new test set. We'll call it sample set. We'll save this set and then we'll open it up. Within the set, we'll go ahead and set the automation host to execute on my local machine. We'll scroll down and we'll add the new test as the test case in this set under model generated folder. There it is, and we'll click save. Okay, now we just need to set the date of execution, and we're going to go ahead and just set the planned date for that to be right now. And then we'll click save on this. Now back on my local machine, I'll open Rapise Launcher and do a force pull, and then I'll have it grab that test and go ahead and execute. So here we see Rapise executing this model-based automation test, and just like that, it's done. Back in SpiraTest, we can see the execution status. We can hit the refresh button and see the execution status on our given test case as well, and scroll down and see each individual test step and its own execution status. 100% passing. And it's just that easy to execute a model-based automation test.
To recap the benefits quickly then, with the enhanced cause-effect modeling add-on for Spira and Rapise, you are able to take requirements from SpiraTest, represent them in a model, and get a very, very high coverage set of tests that is optimized for maximum efficiency. These tests can then be automatically uploaded to your SpiraTest project using our sync feature. And if your organization uses automated testing, our keyword level approach to developing automated scripts can let all of your testers author automation scripts, even those without a development background. These scripts are also easily pushed into your SpiraTest project without tediously uploading them by hand. The Rapise launcher will then see these and execute these automation scripts for you. Since SpiraTest also supports Selenium scripts, the enhanced cause-effect modeling add-on can do the same process with a Selenium framework. This concludes the prepared portion of our demo today. We can now take a few minutes to answer any questions you may have.